Hey guys, welcome to the third episode of operating system. In this video, we are going to discuss about the architecture of operating system. So, system architecture. So, let me take a lighter color. Yeah, that's good. Okay. Let's move on our first slide. What is system architecture? System architecture contains the three things. We decide by the two factor we are considering just like this, and third one what the impact of it. The system blueprint. So system architecture defined as the system blueprint of all the component, how they can be fit in a system or in your computer. The structure and interfaces, how we can design that in our system. The performance impact, what the impact of this kind of a structure on your system, what the overall performance. If you want, we can read this out. Was architecture like a blueprint? It dictate how the system is built, the impact, its functionality, and overall performance. The thing that I discussed about, just the same things over here. Whenever we design architecture, is also affect the functionality and overall performance of your OS. We're going to discuss these things in detail in upcoming slides. Okay, now move on the next one. Here's our first kind of structure, monolithic architecture. So basically, the monolithic architecture is a kind of a structure in which everything that we have in only one larger code base. So everything, either we need to build some system management thing, device management thing, or some memory allocation. So everything is just combined in single file. Example of this kind of systems are earlier Unix and MS-DOS. For process, highly performance and low overheading. Whenever you are in the same file, you doesn't need to be go between the different files. So that's why it's increase your performance. But the con is difficult to maintain, and whenever the single quoted fail, the complete system fails. Let's move on the next one. Here we have the layer architecture. What that mean? Layer architecture is the, let me read out first. The OS is organized into the hierarchical layer. Each layer offers the services to be one above and designed from modularity. So as you see is a kind of layers in our system. So first at the last level we have that hardware, and above that we have that. It's a kind of circular. You cannot be think of like this. You can be think of this like a ball, hardware inside. Then we have the another layer above. Let me change the color. The system calls over here, and then at the end we have the application. So that's how this look like. This is a kind of layer difference. It's a way of representation. It's not exactly in the same manner in the menu. Somehow, maybe it's in some different manner is available in the memory. In the example, include TCP/IP and IP stacks. The structure is debugging. So with this, we are able to track the different level, what the component is available on which level, and we just going to that level and debug that thing. Yeah, we have the microkernel architecture. So microkernel is only the service essential thing, and other services are user space. So what this mean is that just things are mentioned here as well. Minimal, the core functionality is provided to the core functionality in the kernel. Okay, after that, most of the functionality is available. The functionality in this architecture is available in the modular form. So the most of the functionality also available in the this outside kernel in user spaces. User able to access that and passing message communication happen. Yeah, that's the thing. This is the control have in the hand of users. So let's see the example of this Unix and Minix. This is an highly scalable security because most of the controls are in the hand of user, not in the user, but he was able to access everything in this. Most of the only core functionality is suspended from the user if in the hand of kernel. Let's move on the next. We have the hybrid structure. So hybrid structure is a kind of combination of monolithic and microkernel feature. So it have both combined. Some of the spaces have the monolithic architecture, and when wherever needed, it can we can implement the modular structure. So kernel retain the core services or the operator user space. Core services are available other in the operator hand. But maybe the space for the kernel is little wider, so that's why it's saying the monolithic and kernel. Flexible design combine benefit of both. Yeah, it's obvious whenever we have the benefit of the monolithic and microkernel, so we have extra and much more functionality than the individual one. Performance was also really good. But yeah, the third one is risky. Is the kind of its own disadvantage because whenever these two things are combined, is make a hybrid architecture with a kind of complex thing to resolve or debug. So, as example, Windows NT or Linux are the key example of it. An approach offers the flexibility, good performance, complexity, introduction in HTML. As you see, yeah, this is the structure. Okay, move on the next one. Exokernel. So what that exokernel mean? Can we read this out by pausing or I just going to read it? Exokernel provide a minimal hardware resources allocation application gain the direct access to the hardware. This allows the application specific optimizers here. So the minimal hardware resources allocation is for the kernel. Okay, and most of the hardware controls maybe it's allowing some kind of application with which we are able to access the hardware things as well. So so sorry guys. So minimal kernels. So that the minimal kernel is basic allocation thing. In basic allocation thing is the hand of kernel, the direct hardware access. This is a kind of cycle that prepare. It's convey the same thing. Okay, using app optimize the hardware thing. MIT Exokernel. This project was in the hand of MIT. While providing flexibility in architecture complexity, raising security concern, yeah, this the things due to the direct access. Okay, some of the security concern because of the hardware direct access. We're giving the most of the thing in the hand of users, so it's obviously really risky. So let's move on the next one. Okay, here we have the choosing right architecture. Now we can be choose the right one. So this is a kind of draft. It's a comparing three of them on the, it's not the real time chart, so it's maybe some of the advanced system have some changes, but it's the previous one. So this, as you see, we are comparing this on the three aspects. Can be tried if you want. You can be take this screenshot. I hope I don't need to be explain them. If you want to be read, select the OS architecture and do the trade-off. Here that three trade-off: performance, how they can be performed on the system, what the speed and what the response time, the security, what the security concern, how it can be deal with the security, how much secure the system is, and the reliability, how much it's reliable, durable, and it's that relieving features and cross-functional. Yeah, you can be just Google is about the what if you want to be know more about this thing. Okay. So Android for the instance uses the modified Linux adaptability for the optimization. So let's move on the next one. We are the conclusion. So OS architecture is really crucial part of as we discuss as for now. It's really crucial for our security and performance of our PC. Whenever we need the good performance, we need to implement that in really efficient manner. If you want to be know more and in-depth detail about this thing, you can be prefer this. You can just paste this statement in your Google, then you are able to find most of the extra things from here and the modern computer thing over here. So I can also give a link in the description if you want to be know more about these things and in depth detail about this, then you can be check out that as well. It's from the Geek for Geek. It's a great platform to read the things. Yeah, thank you. I hope guys you are able to understand the thing. If you have understand the thing and feel little comfortable with this concept, so please do subscribe and like and share this video with your friend, and stay tuned for the next video, and don't forget to subscribe for because I'm posting that list of the OSI, all the episode of all the episode of rating system in this playlist. So I hope you don't forget to hit the bell icon for the latest update. Thank you.